Now whenever we are mating two surfaces with the help of screws, we have to create holes at the desired locations. So we have already created the bosses. Now the next job for us is to create holes in those bosses. All right. And when I have created those bosses, I randomly place the diameter. I didn't calculate, or I didn't consider what screw am I going to consider for this assembly. So I mentioned in that video that I will be changing the diameter later after deciding the kind of screw which we are going to use for our purpose. All right, so the diameter may change or it may be unchanged. Let us just see what's going to happen. All right, now whenever we have a set of parts being connected with screws and holes, okay, now we have to create two types of holes. Okay, the first one will be a clearance hole and the second one will be a tapped hole. All right, I'll just come back to Google. It helps us a lot to understand many great things. Now you can see, for example, this image. I'm just giving the credit to this website, and you can see that there are two surfaces which will be joining together with the help of screw. And what is the method in which the two parts will be joined is to create two holes at the desired location. The first hole will be named as clearance hole and the second one will be a tapped hole. Okay, the difference between these two holes is nothing but the diameters. Okay, for example, if we are considering a screw which is having certain diameter of thread, okay, the clearance hole will be having a diameter greater than the diameter of thread, whereas the tapped hole, or the hole which the threads meet with, or the threads are tapping it, okay, or threading it, will be less in comparison with the diameter of the thread. Okay, so it is very simple. The first dia will be greater than this diameter, and the second dia where the screw is being tapped, that diameter will be less than the diameter of the thread. Okay, this is because the screw threads will be engaging with the material inside, so it should be lower than the its dia should be lower or less than the diameter of the thread. Otherwise it's not gonna engage themselves, right? It will be just floating in the air, right? So you have to ensure that you create two holes, a clearance hole and a tapped hole. All right, now in our case, if we are coming back to our assembly, I'll just press Ctrl T. This is the upper part and lower part, and I mentioned that we will be inserting the screw from the base. All right, so there should be some hole over here which goes within this boss, the first boss. Okay, and this hole must be the clearance hole, and we have to continue the hole from this particular position, okay, up to certain depth over here, and the diameter of this hole, or this hole, will be the tapped hole. The diameter of this hole will be less than the diameter of the screw which we are considering. All right, now I believe you have understood the logic. There should be two holes being created, the clearance hole and the tapped hole. The clearance hole diameter will be larger than the diameter of the thread, and the tapped hole diameter will be smaller than the diameter of the thread of the screw being considered. Now the next major question is, what is the kind of screw which we are going to use for this connection, okay, or for this assembly or for this joint? Now there is a very famous website called as McMaster. I believe you must be aware of this website, or you might not be aware, but this website is a really classy website, especially for mechanical industries or mechanical oriented professionals. Okay, you will be having all the kind of hardware being listed in this website. You can just check their specifications and categorize them, and each and everything is being listed. Okay, you can just type in Google McMaster-Carr and you'll be entering over here. Now in this website I just searched an entry over here which is thread forming screw, because the screws which we are using will be forming the thread when they are being inserted in this boss. All right, now we will be having different screw sizes, which you might be aware of this thing. We will be having number 1, then number 6, M series, etc. All right, now for this assembly we will be deciding, depending on our the required connections and required strength, etc. We will be deciding what screw to be used. Now in this case I want to go with number 6 screw. All right, so I've selected number 6 over here, and automatically the number 6 screws are being filtered over here. Now we should also select the length of the shaft. Okay, now if you're just coming over here and seeing what should be the amount of, or what is the length of this boss, we can see that if we measure this distance from this surface to this one, it is 0.34. that means it is greater than a quarter inch, right? Now we can just try to go with quarter inch screw, that is 0.25 or 1/4 inches. I've selected 1/4 length. You can also select the drive style, etc., but I'll just keep it as a default. And you can see the different screws being available over here after applying these filters. This is a Phillips round headed thread forming screw for plastic. This is again another one. Then you have this one. This is stainless steel Torx rounded head thread forming screw for plastic. So I'll be going with this screw. Okay, and if you're just clicking on this hyperlink over here, you'll be having certain features, and you can actually go to product details, and you will be having the dimensions being present over here. Right now you can see that the diameter of this screw thread is 0.14 inches. All right, and let us see what diameter did we maintain in our case. I'll just open this part and edit definition. We have maintained 0.35. okay, and the diameter of this one is 0.14 inches, so it's almost double of the required one. So we are under the limits, we need not increase the diameter. All right, we can just cancel this at this moment. All right, and now if you really like, you can download a step file, but before that you have to register yourself in this website, which is of course a free registration. All right, I will be clicking on download over here, and the file got downloaded in step format. The step format is directly importable in the Creo Parametric. We will be having the 3D model of the screw, which can be directly imported in the software. All right, now I'll just come back to the website over here, clearance and tap hole. Yeah, now if we have a screw of number 6 which we have selected just now, okay, now what should be the clearance hole diameter for that screw? Okay, what should be the diameter of this clearance hole if we are basically trying to use a number 6 screw? Okay, now if you just Google in the website, you will be having a chart over here which is tap and clearance drill sizes. Okay, now there are different standards as well. If you are aware of those, you can just go with that one, or whatever your company asks you to go with, you can go with that thing, but I'm just telling in a general point of view. Okay, so this is a chart which will help us to understand what should be the diameters of the tapped hole and what should be the diameters of the clearance hole. All right, now if you remember, we have selected a number 6 screw, so we have this screw size over here which is number 6. All right, and for number 6 we must be having a clearance hole, and again there are two types of fit in clearance hole, which is a closed fit and a free fit. The closed fit will be this hole, or this diameter will be pretty closer to the diameter of the thread, okay, when it is a closed fit. And if it is a free fit or a loose fit, then the diameter will be little bit larger. Okay, you'll be having kind of more airy clearance between them. Okay, nevertheless we will go with one of them, that is not a big issue. So number 6 is the screw size, and the clearance hole must be 0.1440 if you are going with the close fit. Now let me remind you, the diameter of this is 0.14 inches and this is 0.1440. okay, so it is a very extremely tighter fit. So let us just go with the loose fit in this case, which is 0.1495. Nevertheless, in both the cases, the clearance hole diameter will be larger than the diameter of the screw. All right, now let me just come back to our CAD, the lower cover where we require the clearance hole. I will be selecting this surface and clicking on extrude. All right, and we will be utilizing the reference so that we will be getting a center point or the center of the hole, and we will make this as 0.1490 because if we are going to clearance chart, the number 6 is having 1495, which is almost 0.15. I will be creating the same hole on all the other sides. I'm just stopping when I'm getting an equal to sign, which indicates that I'm following the equal constraint. Press OK and remove the material in other side up to the surface. All right, so we have this clearance hole whose diameter is greater than the screw hole thread diameter, right? The next job is to add a tapped hole on the upper cover, which we will be doing in the next video. Let us just move to the next video.